Hi, my name is Amanda Neiley, and this is my presentation on my research topic. I was researching the best ways to improve VO2 max levels and recovery periods for athletes that participate in intermittent sports. In sports such as soccer, tennis, and rugby, as the pace of the game intensifies, there are moments where it's necessary to have explosive bursts of energy. However, with these explosive bursts, it's also imperative that the athlete is able to recover quickly. Athletes at the top of their game strive to gain advantage by being able to sustain that extended sprint or quick tennis recovery in a match for a longer period than their opponent. But they also really need to be able to recover quickly to play a defensive strategy and turn the game back into their favor. Um, Trying to get athletes to the top of their game to be able to do this is why I'm interested in focusing on this study. So as I just started talking about why this is an issue, um, have you ever played a sport such as soccer or rugby and had that breakaway moment during the game where you faked out an opponent, carried the ball down the field, made an amazing run, only to lose possession on a pass, or worse, you yourself got stood up? The next thing that happens is that you have to quickly hope that you have enough left in you to recover and get back onto the defensive strategy. Again, relying on an explosive burst of energy to catch up to that offender. Imagine if an elite athlete had the ability to perform an anaerobic activity at the top of their threshold for a sustained amount of time and quickly recover by improving their VO2 max levels. Not only would the pace of the game change, the lag time while athletes regroup and recover would also be way less. There have been a lot of studies done to see if HIIT exercises and anaerobic activity can improve efficiency, but there's not a lot of research to identify if a repeated HIIT activity has the ability to imitate explosive bursts in a way that can also improve VO2 max levels for sustained burst of energy, which is really what we'd like to gain in our game time and competition modes. For our research statement is that we'd like to research the best training for performance improvement in intermittent sports, soccer, rugby, tennis, and etc., by measuring and evaluating VO2 max levels using formative and summative measures. Specifically, would a test battery of sprint interval trainings and a counter movement jump compared to aerobic activities show greater VO2 max rates for most optimal performance? Our null hypothesis is that there will be no difference in VO2 max and recovery for the sprint interval trainings and counter movement jump compared to the aerobically trained groups. Our hypothesis is that there will be a significant difference and that the HIIT training will result in greater changes in VO2 max. Our dependent variables are our VO2 max, and our independent variables are going to be our two training methods. The HIIT, which will consist of the sprint interval trainings with a counter movement jump versus an aerobic 4-mile run. For our methods, we chose 40 student athletes, collegiate level athletes that were currently participating in an intermittent sport and actively training for that sport, free of any injuries and other issues. We did 20 male and females in each group and divided them into a focus group and a control group. Our control group continued with their 4-mile moderately paced run, and they just did that like they would do their normal training on a track and followed up their times with a stopwatch. Our focus group did a sprint interval and counter movement jump test battery. The test consisted of 12 40-meter all-out running sprints with 30 seconds of recovery broken up into 3 intervals with 3 counter movement vertical jumps following every 4th sprint. Sessions took place under the direct supervision of investigators at the same time and date of each week. To calculate our jump height, we used a Bosco Ergo jump system. Participants completed 3 maximal jumps with their hands on their hips, and the average of these jumps was recorded. 1 minute of rest for complete recovery was given between jumps and before resuming the sprint interval protocol. After the sprint interval protocol, players jumped again, and to know the jump decrement produced by the SIT protocol, we considered the percent decrement of the counter movement jump height and calculated the counter movement jump mean divided by the counter movement jump best times 100. For the sprint interval calculations, the participants did 12 40-meter sprints separated by a 30-second rest. They were performed on a running track with timing gates, and the timing gates were placed at 0, 20 meters, and 40 meters. Standing start with the leadoff foot was placed 1 meter behind the first timing gate. Participants were required to give an all-out maximal effort during each sprint, and the mean sprint time was expressed in seconds as the percent sprint decrement was calculated, and that was calculated as follows, with the SIT mean divided by the SIT best times 100 minus 100. And it was recorded as a measure of repeated efforts performance. All of the participants were given a maximal exercise test utilizing an ergometer treadmill to measure their baseline VO2 max. After preliminary familiarization and pre-testing, all participants began their research testing, and follow-up maximal exercise tests were performed after the study was complete. To analyze the data, we used a standard statistical method to calculate our 2 groups for the mean values and the standard deviation. We also studied the variables by calculating the Pearson coefficient for the VO2 max level and recovery. We ran an ANOVA analysis for repeated measurements, and we also did 2 paired t-tests for each group. We accepted significant changes if the p was greater than 0.05. For both the groups, our evaluation was less than 0.05, so our null hypothesis is what we ended up accepting. Our results demonstrated that there was not a significant difference between our focus group and our control group. Although the spring and jump are anaerobic activities, we were hoping that by combining these with a sprint interval in a repeated fashion, it would be able to improve aerobic capacity. And we hoped that it would improve it in a way that could be beneficial for explosive bursts of energy during competition. The fact the focus group did not gain significant improvements could be due to different variant things. One being that the level of fitness that the athletes already have may already be at their peak VO2 for the particular athlete. The training status might have also been something that affected our research. If participants did not give their maximal effort during their sprint intervals and counter movement jumps, that could have definitely affected the results. Further testing should be done to determine if the training had a positive or negative impact on the level of play and performance during the sports competitions. The validity of the test should further examine explosive power after the high-intensity interval workouts, and also if there's a correlation and improvement in games. A study by Fernandez found significant improvement in neuromuscular performance utilizing HIIT procedures. And these results actually help us to conclude that further testing is necessary to determine if the most efficient means of improving performance can be developed utilizing a HIT model. It'd be interesting to also research if there is a possibility of increasing your VO2 max in some way by a mixed mode of HIT protocol versus, incorporating HIT protocol with aerobic protocol. Here are our references. Thank you so much for watching our presentation and hope that you found something interesting.